Thank you very much for your attention and your patience. Took a little bit more than 30 minutes, and I would be happy now to answer your questions, or you may send me an email later for more detailed information. Rosa?
Thank you, Walter. We got a few questions about how do chlorine dioxide and hydrogen peroxide phytotoxicity looks on the plant.
That depends where it is applied. If it goes onto the leaves, then usually the phytotoxicity is not so high with hydrogen peroxide because the cuticula, the waxy cuticula, will protect it. So you need, I have no figures about, but you need quite a high concentration to get an effect directly on the leaves. But the other point is to get a damage on the roots. And there, if it is, as I said, above 400 or more ppm coming onto the roots, then you will get a root damage. And it's not taken up, of course. It's just, let's say, a burning of the roots, and then you will have an effect on the shoot, as you always have with some root damage. It will chlorinate or will have some wilting effects, and finally, of course, the plant will die. But it's an indirect symptom, just the follow-up of a root damage.
Another question is there any information about chlorine dioxide use in water treatments where vegetable crops are grown in greenhouses? And the vegetables are tomatoes and cucumbers.
Mm-hmm. To my knowledge, with tomatoes and cucumbers, we have no experience. I know that it's widely used in the young plant production of cabbage seedlings, where it is sprayed over the seedlings.
Okay, and
so far, it is not used in hydroponics of cucumber and tomatoes, not to my knowledge.
And then a follow-up question to that is, are there any reasons for not using chlorine dioxide for cleaning water in soilless growing, like rockwool or perlite?
Yeah, the problem, as the European farmers say, is that the risk of phytotoxicity is too high. That's the same reason why they don't use hydrogen peroxide, ozone, or chlorination at all in hydroponics. So it's not so easy to get the right concentration, and the difference between active and phytotoxic concentration in hydroponics is quite small. So for example, just remember a figure about chlorine. So we need 2 to 4 ppm to get effectivity, but in hydroponics, as I remember, it was cucumbers, we had already a damage at 3 ppm of chlorine. And so that is very tricky, and that might be the reason why in hydroponics of vegetables as well as cut flowers, chemicals usually are not used.
Another question is, what is the best way to utilize biological fungicides like Rook Shield in a slow sand filtration or sand filtration systems?
Okay. Root Shield, to my knowledge, is a trichoderma formulation. And to get a good efficacy of trichoderma application, I think it's necessary to achieve a high density of this beneficial fungus in the root zone and not necessarily in the irrigation water, the recycled irrigation water. So the application can be done quite easily via the trickle irrigation or directly by applying a certain amount of spore suspension to each plant. It depends on the facility available. But one point is clear: spores present in the drainage water will be eliminated by the slow sand filter. However, that does not reduce the effect of trichoderma. we did a couple of years ago such experiments, for example, with tuberous in rockwood culture challenged by Phytophthora, with very good results. So I would say yes, root shield and similar products can be used in combination with slow filtration, but put it behind the filter, not before.
And the last question is, when using chlorine dioxide, should one be concerned about salt produced on the reaction?
That is one advantage compared to chlorine, because the concentration of total chlorine is lower with chlorine dioxide. We only use 1.5 ppm. We need only 0.5 down to 0.2 ppm of chlorine dioxide. So in general, we have a lower chlorine load to the whole system. And of course, when we calculate how much is it compared to a standard chloride concentration in nutrient solution, then it's only a very small part. And so if you have not a crop which stands several years, then according to our measurements, we will not have a problem with too high salt content.
Okay, and now I'm going to switch to Paul because he has a picture about how the hydrogen peroxide phytotoxicity symptoms look like.
This is 1 to 1,000 1 to 1,000 ratio for a xylitol solution. I'm not exactly sure what that translates to in parts per million. I'd have to check that. But the xylitol label for applying the solution through a mist system ranges from about 1 to 1,000 to 1 to 5,000. We haven't seen damage at 1 to 5,000, but Taurinia, which is in this photo, is a very good indicator plant for phytotoxicity.
That's true.
And another question which was on phytotoxicity from chlorine dioxide. This is chlorine, but it's actually chlorine dioxide. This is a photo from Dr. Royal Hines shared with me, and it looks very like some of the phytotoxicity symptoms that we've seen from chlorine, where basically we're oxidizing, burning holes into the foliage, which can sometimes then darken over time. So just for whoever it was that sent in that question, there's a couple of quick images to recognize what some of the symptoms are. Depends on the species as well. In these two photos for the xylitol and chlorine dioxide, the dots look white. They'll look darker and even black on certain varieties.
Okay, thanks, Paul. And thanks, Walter. I think with this, we'll close the webinar. Thanks for joining us today.
Okay, bye-bye.
Thank you.